Hey, it's Tucci again. Some basic things to go over with your control valve inquiries. So first and foremost, if you're discussing with a customer or an engineer the need for an automatic control valve, the biggest thing is to understand from them what they are trying to accomplish with the valve. All too often do I see people or experience people calling saying, I need a control valve, and they just start rambling on about needing a valve for their system, but they don't truly understand what they're trying to do. So in your conversation, steer your conversation with your customer, with your engineer, with your contractor, whomever it may be. If this is a replacement valve in the field, it's fairly simple. As long as their requirements have not changed, find out what's in the field, what are they using, what model, what manufacturer, etc. A picture's worth 1,000 words. If you can get a couple shots of what is in their system currently, that will help us help you. If this is a new application, again, what are they trying to do? I've had applications in the past that start with the exact conversation, hi Jim, I need a control valve. We see that you sell automatic control valves. Once I start asking questions and once I start understanding their system, it's not always an AWWA C530 valve that we end up selling them at the end. So again, understand the system, understand what they are trying to do, and we will figure out the best valve for their application. If everything does lead towards an automatic control valve, pilot operated style, we're gonna need certain information. Again, first and foremost, what are they trying to do? Are they filling a tank and they don't want the tank to overflow? Do they have a high incoming pressure and they need to have a steady, stable downstream pressure? Is it a pressure relief valve for a large system? These are just a few of the many applications that are out there. So get that information. Next, what is their anticipated flow rate through the valve? What is their incoming pressure? What is their desired outlet pressure? How tall is their tank? Where are these valves going to be located? Is it in a basement? Is it in a vault? Is it in a pump house? Okay. What size pipe do they have? I warn you here, just because somebody's got 12-inch pipe does not mean that we would recommend a 12-inch valve for the system. That's going to come back to our question about what is our anticipated flow rate. These valves need to be sized such that they're not open too little, but they're not open too wide for the majority of their life. We want these valves to operate in a nice sweet spot, okay? So too low of a flow, the valve's only going to crack, potential for premature wear. Too high of a flow where the valve goes wide open, exceeding, say, 15 feet per second for a good portion of its life, again, the valve can probably handle it, but the potential for premature wear exists. Also, with your pressures and your flows, is there potential for cavitation? We need to analyze each system based on the information provided to us from the customer or the engineer or the consultant, whoever it may be, and we can run calculations to diagnose whether cavitation is a potential risk. Also, let's confirm that this is clean water. These style valves are designed for clean water and clean water only. These valves require certain components that are very susceptible to dirt and debris. If we have anything than a clean stream of water, there's potential for these components to clog. Therefore, this valve may not function as designed. Another thing to consider is the configuration of this valve, or location of the valve and how it's going to be configured in the pipeline, shall I say. Is this valve going to be 12 feet in the air? Is this valve going to be installed horizontal? Is this valve require an angle configuration? These are all questions that we need to ask at the beginning. Let's figure out what is going to work best for the application, what is going to fit best into their working space, and give them the best, longest lifetime possible. Other things that should be considered when asking questions of your customer: where is this pipe going? Where's the discharge of this pipe going? Is it in an adjacent building? Do we have 5 miles of pipeline we have to consider? What is the topography across that 5 miles of pipeline? There may be other valves that we may recommend be installed in our system to work in conjunction with this valve so the system operates correctly. Our control valves are available with AIS compliant and BABA compliant configurations, so it's also important to understand if there will be federal funding required or federal funding available for this project so that we can supply the proper documentation and utilize the proper bill of materials when configuring and building this valve. We do have a sheet available that will help guide you through the questions that you should ask of your customer or the engineer. This sheet will cover most of the points that I've already stated, also along with various elastomers that are available, which would consist of Buna, EPDM, or Viton. These different elastomers may be important based on the media and any treatment in the media, taking into consideration chemical compatibility and lifetime of the elastomers. Based on the information required and provided to us at the time of order, a product-specific part number will be built. Our basic models do exist, however, there is a long part number. Finished part numbers are based on the information given to us at the time of order. This part number will be inclusive of the elastomers chosen, the trim chosen, size, pressures, etc.